Hi, I am Dr. Sridhar. This is hands-on project I made as a part of Databricks Codebasics AI project challenge. So on coming to the project, I took a domain, healthcare domain. So coming to the problem statement in healthcare, patient with a chronic disease often requires multiple follow-up for their treatment. Often these chronic disease patients often fail to follow up, often fails to revisit the hospitals. It ends up in progression of the disease more and more, and they end up in advanced disease which is beyond the cure. So that it is better if we predict the model, if we train the model and the model if we able to predict this type of the patients so that we can do better motivation, better health education for them to revisit to the hospital. In this healthcare domain, if the patient not comes to the hospital, it doesn't mean that they will go to other hospital. Probably they will not come to the hospital and end up in worsening their disease condition and leads to health burden in the society. So for the problem to get reduced, we are planning to develop a model to predict these type of the patients. And for this, I took a data set from the kaggle, which is the patient churn data set for the healthcare. In this coming to data set general overview, it is consists of nearly 2000 data. In with there are 21 columns. Out of these 20 columns is the futures, where one column is the name churned, which gives whether the patient is churned, not fail to follow up, or not churned, patient is having regular follow up. So we are planning to develop a model which is going to predict these patients so that we can give better treatment and follow up for these patients. On coming to our whole workflow, we will take the Kaggle data raw CSV files and we will convert this CSV file into the bronze table. As it is, the whole data file is the whole CSV file is copied into the bronze table. Then we made some future engineering into this table or a CSV file so that this is converted to the proper dataset. And we need to do pre-processing the dataset, like category columns should be for encoding and numerical columns should be scaled. And finally, we will train the border data and we need to register the model and pipeline. And later in second part, what we'll do is that we will create a new synthetic data with the help of the Python code and we will apply this model to the new synthetic data. And this new synthetic data won't have the column of prediction that is churned. So that we will put the model to predict that column. And based on that, we will extract some file into a gold data. And this data we will take for the development of the dashboard. This is our overall plan. And coming to setup, here, this is the Databricks user interface. For the whole project, we will use the Databricks from end to end part. So Databricks, what we made is that in the workspace, Databricks workspace, we created a folder of patient churn prediction. In this, our all the codes and everything will be written for this project. So once we goes to the inside this folder, we will have the entire notebook. We will go step by step in the coming slides. So another thing, we will need to create a catalog. In this catalog, we created the catalog of patient churn prediction, where all our data will be stored in this catalog only. And in this catalog, the layer is second layer schema. The default schema information will come by default. So we created the three schemas: log model, patient data, source data. And this log model, we created the um, log model volume into the log model schema, where source data, we created the source data volume into the source data schema. So what we did is that in the source data only, we took the Kaggle data set and stored in this schema, stored in this source data volume from the source data. So this data only we used for training the machine learning. So this data we can directly extract from the cable with the help of the code, or it will be stored in some Amazon, Google Cloud storage buckets. so that we can extract with the databricks many things. So for the understanding purpose, I kept this CS file in this volume source data. And after that, we need to have the setup. In that workspace, this setup file, we first made it. And as I told, first we created the catalog with the patient churn prediction catalog. Inside the catalog, we created the log model, patient data, source data schemas. In the log model schema, we created the volume of log model. In the source data schema, we created the volume of source data. This is the initial setup. In this part, we are going to train our model on the Kaggle dataset. So, our Kaggle dataset is stored in our patients and prediction catalog, where the source data schema, and in the source data schema, there is a source data volume we created, where our Kaggle dataset is getting stored. And with the help of notebook, where we created a ML train named notebook. Here, what we are going to do, we are going to train our ML model on the Kaggle dataset. So initial setup, we install and import the dependencies. Once it is dependencies, we need to configure the ML flow. Here, first thing we need to create a temporary directory. In this, it should be a volume. That why we created a volume log model in the log model schema. This is the model which stored the temporary path of the model like this. And once we need to create an experiment path here where our experiments will getting logged onto it. With this is we stored in our workspace environment. After that, we taken extracted the data from the Kaggle dataset from that volume and stored in the bronze data frame with the help of this code. Once it is taken, bronze data frame, here when analyzing this data, we can found that the patient ID, which we are not going to use, but some are categorical columns are there like age, gender, specialty, insurance type. Some are most all are numerical column, but one column is the last interaction date. This is the patient interacted in the last time. So to convert this date into a numerical value, what I did is that I took a default date of 25 January 2026 and I calculate the number of remaining number of days happens is the last interaction to the current date, and I added as a another column as days since interacted, and I stored again it is in the bronze DF data frame. So new data frame it shows that another column which is days since interacted. Now, important point pipeline damage. So here our machine learning model categorical volumes usually we will do one not encoding, but in Spark ML the one not encoding is slightly different. So initially we need to do indexing the column like categorical columns. For example, if you want categorical column have five unique values, it will first index, and from the index it is stored as a one not encoding setup. It is different from one-not encoding for as a scikit-learn. Here what will happen is that it will store as a single column, even a column having six unique values. It is converted to index with the head of indexer. And these six unique values is stored as a single column only, not a six columns. And this single column, it is stored as a vector. That way, even number of distinct values how much, still it is stored as a one not encoded single column. Here we have four categorical columns, and these four columns is taken as the four columns of one not encoding after converting to indexers. And now the numerical columns, integer columns, we extracted and we not included churned column as well as those who entered the index, because previously we created the indexed column. This column we should not take. So we avoided these two columns and all the integer columns is taken. And in Spark ML type, what it will happen is even the number of features that all it converted into a single vector assembler, and this feature is trained to predict the outcome. That's right. That's why this all integer columns with the help of vector assembler, it is all vector assembler. It is all integer columns converted to a single column named integer features. After this single column is integer features, we apply the min-max scaler to scale the columns. Then we, from the integer features column, we created another column called integers features scaled column with the help of min-max scaler. After this min-max scaler scaled integer features scaled column happened, we combined all these four one-not encoding columns to integer feature scaled columns to as a single total five columns we combined final and named as final inputs. And again we used the master vector assembler, and these five columns also we converted in the single vector column. So after that we made a pipeline. In the pipeline, first we made an induction, indexers, four indexers, followed by one not encoding, number assembler, scaler, and master assembler, all converted to a single pipeline. Now we split our data bronze data frame into train and test data frame. This should be done before scaling and one not encoding. First we need to split, and we need to apply this pipeline model only in the train data frame, not in the test data frame. Otherwise, it leads to data leakage. So once we made a pipeline model after fitting with train data frame, this model we need to use to train will transform the train data frame test data frame as, and we got two data frames, train transformed, test transformed. So after train transformed, test transformed, two data frames we created, we try to training the logistic regression model. In this logistic regression model, we take the logistic regression where your future columns is a single future column which is one not encoded, scaled, and vector assembled, and label column is the column churned, which is our output value. And we will fit the model, and we will predict the model, and we will log all the parameters with the help of ML flow, and we will record these things. And finally, one important thing we need to do is that while logging the model. So we will train and everything, and we will see the result. We are planning to log this model. So for log this model, we need to should not log only the model, because when the real data set comes again, new data set, it contains all the column which is not one not encoded, not scaled. So we need to bundle all the pipelines along with the model and convert it to a single pipeline model, and we need to log that pipeline model into the log model. Like here, what I did is that final pipeline model we conducted. Initial pipeline model stages all gives the list of model like a standard killer index view list. Along with that, we added the model logistic regression, which is we trained it, and all it is converted into a single pipeline model and stored as final pipeline model LR. And this the help of this name we logged this model, and the name we given is that pattern patient churn log reg. This is the name we given, and if we run this, it automatically store this model there. If you again run this with the same name, it will store as a version 2 and followed by version 3. If you run as a different name, it is stored as another model in this way. And we got the result from the test accuracy, trained accuracy, and based on this. Similarly, I trained this random forest model and predicted the result, and we again logged everything is there. On coming to the result part, some interesting. In case of logistic regression, we saw the recall value, which is sensitivity is 0.94. In the test train as well as in the test is 0.95. Very good. And accuracy is 0.68 in the train and 0.70 in the test accuracy. Again, it is not overfitted, underfit model. At initially, it seemed like a good model. But if you see that the recall value of the 0 is 0.13, where here is 0.12. That means it is giving most of the value as a 1 and only less number of value as a 0. That means, like example, if there are 2000 patient is there and if 1200 patient is labeled as 1, it tend to give 1800% as a 1. So end up in covering all the 1 patient. That way you are able to see the recall value as 0.94. But however, the recall value as 0.0 is only 0.13. Again, it is not a good model. So what we need to do is that we need to change the hyperparameters or some of the scalings, and we need to keep on training the model so that we'll get the better results. But I did many changes and things, still I'm not getting the better results also. Not better results. And coming to random forest, again it is very more worse. It gives the recall of 1. That means it is predicting 99% of the value as 1. So again not good. So we did to calculate the probability value and calculate how the risk is there. This I will explain later. So main thing, the problem here it came because of some probably three reasons. One reason, we have the data set which is not actually, features are not actually help in representing the output value. Probably the data is not good. First one. Second one, we won't have the enough number of the data set. Like 2000 is not enough. If we take 20,000 or 10,000 data, that time it may be better. That may be second reason. Third reason, whatever we did the future engineering and this thing, there needs some more future engineering so the data can be taken. These three reasons can be reason for the model to perform better. Okay. And after this training and logged the model, we able to see the model. When compared to catalog, in this log model, it is a temporary data file which is stored here. Where in this default, these are the various models it is stored. If we go to log regression, every time I run, it is stored as version 1, version 3, version 4, version 5. If I change the name, it is stored as another model. And whatever the experiments we do, these experiments are stored in patient churn analysis, the name, that is the thing. And these experiments will look like that. And we can able to see the metrics, accuracy metrics and everything. And we can compare the model and it is logged there. That is the good thing. So on coming to this second part, we initially trained the model from raw CSV data and various pre-processing steps we did it. Finally, we trained the model with a registered pipeline. Finally, this is the thing, categorical column we made as a one-hot encoding after indexing. Numerical column we made a vector assembler and scaling we did it. Finally, these two things we made and as finally vector assembler. And finally, this vector assembler, we trained the data and we tested the accuracy, everything along with the test set. This is the thing we did it. And this is the experiment column, various experiments we did with the help of ML4, it is registered here. And next is our third step. In this step, what we do is that we will create a new synthetic data with the help of Python code. In this synthetic data, what it will do, we will store it and we will retrieve it from the volumes, and we will do some feature engineering, convert to the bronze layer and silver layer data, and we'll apply our registered model into this data to predict the outcome. And with the help of this outcome, we will make a one gold table and we will make it a dashboard based on this table that we will do. So these are our registered models done on previous ML4 training, and finally we will get the gold table like this. So on coming to this notebook, it is the synthetic data notebook, and here I made a code in that it will create a synthetic data similar to our kaggle dataset data. In this synthetic data, we won't have the column outcome column like churn. Apart from them, it will create a random column into this. And this column we will store as a new patients, and we will store in the source data cat volumes or source data schema. So this data will stored in this source data, where previously in the source data, in this volume we stored our Kaggle data set. In this table we will store our synthetic data. It is, we will think this source data as an external one. Here we will store the external data of this thing. Now, this synthetic data is the new incoming data. In real world, this data will coming as a daily basis from extracted from the applications and various sources, and it getting stored. And it will be either stored in that Amazon S3 storage bucket or Google Cloud, wherever it is stored. And this database will help in retrieving that data, and we will do the modeling. From there, after synthetic data, we will have a bronze notebook. This bronze notebook, we created a bronze data frame by reading this synthetic data, and it has the all similar to the kaggle dataset, but we don't have any churned column, which is the output column. And this bronze data is stored in the bronze patients data table. So it is stored in where I created a patient data schema. Here the bronze patients it is stored here. This is the first level of storage layer, and most of them they will store as a bronze layer with a timestamp and source also. Here I didn't do that for the simplicity purpose. And after the bronze data, we create the silver notebook. Here we will read the bronze data frame. Once the bronze data frame is found, we did the future engineering. Like that, we created one column called days since interacted from the last interaction date, similar to our ML flow training. So once we created it, and this data we stored as a silver data frame. And if you see the data frame, we will add a one more column called days since interacted. And this data frame is stored as a silver patients table. In the same patient data schema, it is stored as a silver patients. Then after that, we created the gold notebook. Here we will take a silver patient's data frame, and we store as a silver patient's data frame. And after the storage, we create again a temporary path, and we selected the path of the our model as a model URI, and we will load the model, which is the patient churn log rate and version 4, which I did it, and it is stored in this. Once the model is stored, we will create a prediction data frame with this nodal model, which transforms the silver patient's data frame. See, this loaded model not only contain logistic regression model, it is containing string indexer, one not encoder, and a numerical vector assembler, scalar, along with model logic. So whole bundle pipeline is loaded, and it transforms our silver data frame. So once the predictions comes, and these predictions it contains all the columns. If you see that, along with these columns, it also contains one not encodings of the all the in a first indexing of the all the categorical variable, one not encoding of the all the variable, and integer futures, and integer future which is scaled, and the final future. This is the futures where the model take it for predicting the value. So it will only take this column only for predictions. So finally, it will give the probability value. This is the logistic regression. If you learn, it will give the number between 0 to 1. And if the number is greater than zero point 0.5 probability, the prediction will be 1. If it is less than zero point 0.5 probability, the prediction is 0. And this probability is stored as a vector score here. And finally, it gives the prediction as 1 and 0. So once the prediction is 0, here I started to make a gold table. Here, as previously told, our logistic regression try to predict most of the values as 1. So to reduce that, what I made is that I, along with that predicted column, I took a probability of the prediction also another column, and I stored in the gold table. So what that I made another prediction with probability with with this code. It will create a one more column as churn probability, and with this stream I created a gold table with that, and this gold table look like this along with the only gender, age, state. Here if we goes that churn score, this is nothing but the probability of the prediction. Like if the score is greater than zero point 0.5, it will give us 1. If it is less than zero point 0.5, it will give us 0. And I calculate the score, and in this we can infer that if the churn score is above like zero point 0.8, zero point 0.9, the probability of the patient not following up is more. So that instead of checking all the patient, we will go consider the high probability patient also. In the logistic regression, we can keep the threshold 0.6, 0.7 also to reduce this type of things. But here I took entire churn score for this, and I made a another column with the risk segment, like if the probability is greater than zero point 0.9 very high risk, 0.75 to zero point 0.9 high risk, 0.6 to 0.75 moderate risk, 0.55 to zero point 0.6 low risk, less than 0.55 very low risks. This I made in this column. Once I made this column, you will see that very high risk, moderate risk, low risk. And this gold data again, it is stored in gold data frame. This gold data I stored in the gold patients column. Like here, from the patient data schema, it is stored as a gold patients. Another one more churn data to look for what is the churn probability and description. I made another column and I stored in this churn data column. After making the goal table, we will build a dashboard. So before building the dashboard, what we made is that actually till now what happened, the new synthetic data will come and it is processed and finally it gives the goal data goal table, which is having a very specific values and these things. And every day, every hour, the new data will be coming out. So that we need to run again the bronze layer, silver layer, gold layer. This can be done easily with the job run. Here, what we did is that we did the job run, and so we made a pattern churn prediction named job run. What this job run will do is that what I did is that I created a job in that way. Once if I tell it is run now, it automatically wrote the bronze notebook and it will run the bronze notebook, and again it will load the silver notebook and runs the silver notebook and the gold notebook, so that our data will automatically converted and come to the goal table. Instead of manually running it, we can add the triggers also. Like if new data comes, it will run. Otherwise, on particular day, it will run. We can add the triggers also. In this way, the things we will make it as automatics. And finally, next step, we will see how the dashboard has been done. So after the job runs, we had the gold table. From the goal table, we will create the dashboards. Here in this data, we will do the SQL query to select the goal table, and we can do various queries also to select the particular part of the table. After selecting it, we will go through it and we will do develop the dashboards. It is very simple dashboards. Sometimes, most of the time, we can use the AI to create the dashboard also. We need to give particular parameters and it will create the dashboards. And once you select it, we can change the widgets here and we can change the parameters here so that we can change the dashboards color and various data also we can change. And these dashboards get automatically updated for every job run. If you do job runs, the new data will come and it's stored in the goal table, and it is dashboard will get updated. Here, one thing I need to tell, for every time there is no need to save a proper table. We can save a materialized table or just a view table also to create the dashboards. And also there is a one thing called streaming table. What it will do is that any new data comes out, it will only read that data and it will store it. So instead of reading entire data, it only read data and store it. This is the use of streaming table. This type of tables we can store in Unity catalog schemas in the databricks. Finally, on coming to the final slides, we created the goal table. After creating the goal table, we added the dashboards, and this is the main part, governance. Here, the governance is that we will give permissions to particular people. Like example, for this real data, we can give the data analyst team assess. For some ML training data, we will give them ML team thing, so that with the help of the permissions, we can make particular people to access particular data, and whole governance can be monitored from the single platform. This is the main advantage of using the Databricks. So final conclusion on coming to our model still not performed better. It may either due to the data insufficiency or whether the churn occurs actually due to random, not depends on the futures. And finally, it triggers some more future engineering to train the model. Otherwise, we need more data to retrain the model. So what we need to do is that any incoming data, we need to assess the how the data is coming and what our prediction is that and what is the real outcome is that. And if the new data set comes, we need to retrain the model and we need to use that model for the new data. But on coming to the Databricks, it is the best unified platform. It can do end-to-end process from the data ingestion to engineering to processing and analysis and train the ML model and recently AI models. We can do everything with the end of single platform called Databricks. And it also provide the governance, data governance also with Unity catalog volumes. And it also provides seamless connectivity to various other platforms. Like if you want to develop a dashboard in Power BI, it has a seamless connection into that. So it has also have seamless connectivity. So thank you for the listening. This is my whole project as a part of Databricks Code Basics Project AI Challenge. This course I will upload in the GitHub page. So if there is any suggestions, please feel free to connect with me. I will try my best to answer as well as to change everything. Thank you for the patience. Thank you.